All right, so our first learning objective in the AP, so it's still our unit 4, but the AP unit 3 is the chain rule. All right, so the chain rule is when you take the derivative of something inside of something else. You just take the derivative of the outside and keep the inside the same, and you multiply by the derivative of the inside. So I'm trying to take this first derivative. The 3 exponent is the thing most on the outside, so I'll bring the 3 down and then put a 2 there. And all these have that already. But when you do that, you keep the inside the same. So the thing in the parentheses, all of that should be the same, which means now A is out because the thing in the parentheses is different than up there. All right, but all these you can see is basically just copy and pasted, all right, down. Then I need to multiply that by the derivative of the inside. Right? So this part of the inside is also another chain rule problem. Cosine is going to turn into negative sine, so it's going to be negative sine. And the inside stays the same. But then I need to multiply that by the derivative of the square root of x, because that's inside of cosine, which is 1 over 2 square root of x. Which makes it look like D is going to be the right answer, but let's just double check. Then I'm going to subtract the derivative of the natural log of x squared. Well, the derivative of the natural log part, which is on the outside, is 1 over the inside, times the derivative of x squared, which is 2x, and that simplifies to 2 over x. All right, so the one that has all those pieces together is D. All right, so D is our right answer. Did the first chain rule, cosine of square root of x turns into that piece, natural log of x squared turns into that piece. All right, but again, it's just the chain rule following each piece. For 14, h is defined as putting g inside of f. All right, so when we put g inside of f, we're taking all of this and putting it in for that x there. So it's going to look like 5. Instead of x, we're going to write all of g of x to the 4th. And then when we take the derivative of this, because we want to take the derivative, all right, the most outside thing is that power of x, so that's going to come down. And we subtract 1 from the power, and then we multiply by the derivative of the inside. Right, the derivative of e to the 2x is 2e to the 2x. Derivative of x is 1. All right, so we're just looking for the one that looks like that, and that looks like it's C. All right, some of the other ones, the inside didn't get exactly copied, so that's not right. This one doesn't do the second part of the chain rule of multiplying by the derivative. This one is, you just did the derivative of the inside and nothing with the outside. All right, so C is the only option that makes sense. I have f is sine of h of x. All right, what is its derivative? Well, we start on the outside, so the derivative of sine is cosine. We keep the inside of the parentheses the same. And we multiply that by the derivative of the inside, which is just h prime of x. All right, so that's just going to be C. And this one, we're taking the derivative of tangent of e to the 6x. So we saw that there's some stuff from previous learning objectives. All right, we start with tangent on the outside. Derivative of tangent is secant squared. But we keep the inside the same. Then we multiply by the derivative of the inside. All right, e to the 6x, its derivative stays the same because the derivative of an exponential is the same. And then we go into the exponent, that's 6x, its derivative is 6. All right, so we have 3 different parts as we work from the inside out. So we did tangent first, then the exponential part, and then the 6x part. And that gives us that there for our final derivative using the chain rule. All right, so the next learning objective is implicit differentiation. All right, the main thing to remember with implicit differentiation is to add the dy dx, right, when you take your derivative, take derivative of a y. So every single time you're taking the derivative of a y, you're going to add that dy dx afterwards. All right, so for this one, we're trying to do the implicit derivative. So the first thing we do is to take the derivative of e to the 2y. All right, it's actually a chain rule because we have this 2y inside of e. So e to the 2y times the derivative of 2y is 2 dy dx. All right, minus, all right, again, an exponential, so e to the y squared minus y times the derivative of the inside is going to be 2y dy dx minus 1 dy dx. And that's equal to the right-hand side. The right-hand side doesn't have any y, so we don't have to do any of the dy dx thing. We just do our normal chain rule. And then it says we want to find dy dx when we have the point 1, 0. So there's two options you can go here. You could solve for dy dx first and then plug in your point, or you can plug in the point first and then solve. Generally, for these more complicated equations, it can be easier to plug in the point first because some things will go away. So we want to plug in 0 for y, and 1 for x. And it's already gotten a little bit simpler because this term here, where there's just a y being multiplied, cancels out. E to the 0 is just 1, so both those are just a 1. So now it becomes 2 dy dx plus 1 dy dx equals 4 minus 2 is 2. That gives us 3 dy dx is equals 2, and if we divide by 3, we're going to get 2/3. All right, so this is 3 of them, and that's going to be divided to give you that 3 on the bottom there. All right, so the final answer here is 2/3. And that's generally the case. If you already have the point, it makes more sense to plug in the point before you solve for dy dx because sometimes it'll simplify much nicer. 18, we're trying to find dy dx, so we actually have to do the whole thing. All right, so if we take the derivative of the left-hand side, the derivative of y is dy dx. The right-hand side, chain rule, take the natural log first is 1 over whatever's on the inside times the derivative of the inside, which is 4x minus 6y dy dx. All right, now we want to try to get the dy dx just by themselves. The first thing I'm going to do is we have this kind of fraction here, so I'm going to multiply both sides by 2x squared minus 3y squared. Because that'll cancel out there, but on the right-hand side, now we don't have a fraction anymore. And now I want to get all the dy dx's together on the same side, so I'm going to move that 6y over. And now that I have the dy dx's on the same side, I would pull it out to the front and divide. So this is going to end up being on the top, and all of these pieces are going to be on the bottom, so the right answer is d, right? 4x is the only thing that should be on the top of the fraction, so it's between b and d. But on the bottom, there's going to be that 2x squared part, that minus 3y squared, and a minus 6y part. All right, so b is missing that 6y, which is why it's not right. All right, 19, same thing. I think you have to remember here is whenever you multiply an x times a y, you have to do the product rule. So the derivative of 3x squared is 6x. All right, this is 5x squared times y squared. So if I keep the 5x squared the same first, all right, and I take the derivative of y squared is 2y dy dx. All right, then I keep the y squared the same, and the derivative of 5x squared is 10x. And that's equal to the derivative of 2y is 2 times dy dx. And one thing you can start kind of seeing is that the things that have terms that have the dy dx are going to end up on the bottom of your fraction. The terms that don't have dy dx are going to end up on the top of your fraction. So right away I can kind of see my answer is going to be 6x plus 10xy squared all over 2 minus, what's that, 10x squared y. All right, so I'm looking for one that looks similar to that. All right, this one doesn't have enough stuff on the top. This one has too much stuff on the top. This one also has too much stuff on the top. And this right answer is B. It doesn't match exactly our problem, but if you change everything by a negative sign, make that negative, make that negative, make that positive, make that negative, now it matches that answer B. And if you just multiply everything by negative, it's still the same expression. Right, but same idea, taking the implicit derivative, finding out what dy dx is. All right, same thing here. The only thing that's different for this one is you have to do the quotient rule. So original bottom times the derivative of the top minus the original top times the derivative of the bottom all over the bottom squared. And the right-hand side is just the power rule. right, first thing I'm gonna do is multiply both sides to get rid of the fraction. Then I'm gonna subtract y to get the dy dx thing by itself. And I divide to get my final answer. So my final answer is dy dx. All of this is on the top. And I just divide by negative x. All right, so this is my answer for that problem. All right, and you can see all the implicit problems take a little bit of work because you're doing a lot of individual derivatives, and then you're combining things and moving things around. All right, but as long as you're careful with your notation, you kind of follow where each piece is going, you should be able to get to the final answer. All right, so the next learning objective is about inverse functions. So the important thing to remember with an inverse function is if you have a slope of a tangent line of the original, you do 1 over that for the slope of the tangent line of the inverse. All right, so we have some information about f and some information about g, all right, and they're inverse functions. All right, so what does this tell us? Well, the first thing is if f of 3 equals negative 2, it tells us the point 3, negative 2 is on f, which also means the point, if we flip it, negative 2, 3 is on g. We also know g prime of negative 2, which is this x value, is negative 4. So g prime negative 2 equals negative 4. And if we switch these back, then for f, the x value becomes 3, because there's the relationship between the x values of the inverse and the original, and that's just 1 over that answer. All right, so that's what we get by using this inverse function theorem. The f of 3 has to be negative 1/4, so the thing that has to be true is 2. All right, nothing else has to be true because it's away from this relationship that we have since negative 2, 3 is on g, 3, negative 2 is on f, and that's the important x value for what we're doing. And this one's really the same thing. We plug in 4 into g and get 6. And the slope of the tangent line at 4 is negative 2. What about the inverse of g? Well, instead of doing 4 for the inverse, we do the flipping part. So for the inverse, we're going to have 6 is what we care about. So b is out. Like a 6 is actually the x value that's going to go into the inverse. And then we do 1 over that answer. So negative 1/2 is d. Now here we're trying to find f inverse prime of 3. So the first thing to do is there's nothing else here about f inverse, so we had to go back to the original. Well, this is the x value for the inverse, which means it's the y value for the original. So we're actually looking here, which tells me the related x value is 1. All right, so this is the important row, because that's where the y value of the original is 3. That slope is negative 4. So if we do the inverse function theorem, we just do 1 over that, because it's 1 over negative 4, which is negative 1/4. All right, this one's worded a bit weird, but we have a tangent line of the function f at x equals 1 is 3x minus 1, and we want to use this to find any equation of a tangent line for the inverse. And of course, based on the limited information, we'll only be able to find one answer. We can't kind of just make up random stuff. And what we know is the original, the slope of the tangent line is 3, because that's the slope of this line. We also know from the original, if we plug in 1, we get 3 minus 1, which is 2. So the original has the point plugging in 1 and getting out 2. So what does this tell us about the inverse? It tells us the inverse has a slope of, remember, it's 1 over, and the point flips to the point 2, 1. All right, so really we're just going to use these values, y minus 1 equals 1/3 times x minus 2. All right, so the opposite slope and the opposite point. And if you wanted to, you could simplify this, but I'm fine with leaving it there because it doesn't necessarily tell you to put it in slope-intercept form. All right, so that's our second video. I had a lot of the big things that we've learned in this unit. So the big thing being the chain rule. All right, that gets used a lot throughout all calc. implicit differentiation, which is really making sure you know how to do derivatives and you're really careful with all your terms and those dy dx's. And then this inverse function theorem, really knowing how the relationship between the inverse and the original. All right, so the slopes are just reciprocals of each other, and the points are the flip of each other.